let's see the first of our beautiful new constructs. The first one will be list comprehensions. Let me motivate this by asking you to solve a problem for me. And in fact, I kind of give the solution here, but think in your head, yeah, if I asked you to make me a list of the powers of 2, starting from 1 to 10, so 1 to the power of 2, 2 to the power of 2, so on and so forth, how would you do this? Well, today, you all are familiar with how to use a for loop. You could probably create a list, iterate over a range. So you'd use a range to get a sequence from 1 to 10 inclusive. So that's why we have 1 to 11 here, because the stopping point is exclusive for range. And then you'd probably compute 2 to the power of, I. So first 2 to the power of 1, 2 to the power of 2, and so on and so forth. And you would append that to your list. And that would give us the result. This actually seems reasonable, but Python people would look at this and say, wow, this seems like a lot of lines. Can we do better? This is where list comprehensions come in. So list comprehensions give us a way to quickly and easily generate a list that involves iterating over some existing sequence. So here we have the syntax for list comprehension. Now notice, this is the brackets that we're used to seeing for lists. And inside of the brackets, we have this long expression. Now don't look at this and get scared, because it is a lot of things. There's, expression, for, element, in, sequence, if, conditional. This syntax is designed to be read like you do in English. And so you look at this and you say, okay, I'm going to compute this expression for each element in my sequence. And I only compute the expression and add it to this list if this conditional is true. And this conditional part, by the way, if conditional, not required. You don't have to have it. If you want to compute some expression for every element in the sequence, you can just leave off the if conditional part. So again, the important thing here is inside of brackets, we have this construction, expression for element in sequence, if conditional. And this will be an expression. This whole thing is an expression that then evaluates to a list following this kind of English reading of what this list comprehension says. So let's take a look. For that same problem that we were doing before, if we wanted to generate the first 10 powers of 2, this is how we would do it. We would say our expression is 2 to the power of I for each I in the sequence, which is a range from 1 to 10 inclusive. 2 to the power of I for I in range 1 to 11. So what this does is, for each number, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, it'll take 2 to the power of that number, and then this is all inside of a list. And so look at that. This is the same as this code here. And I'll just show you. Let's take this code and run it over here in my replit. So I paste this in, powers of 2. Yep, and there we get our powers of 2. So I'll just come in here, Python 3 .py. Yep, those are our powers of 2. Now let's write this as a list comprehension. So our syntax was, inside of brackets, we do the expression we're going to do. So that's going to be 2 to the I. And how do I know it's I? Well, it can be whatever variable name you choose. So here I'm choosing to call this I for I in range 1 to 11. But I could also call this, I don't know, I could call this num, pow. Sure, I'll call it pow. Like that. Or I can call it, let's do exp. So 2 to the exp, so for exponent, for exp in range 1 to 11. And now I'll just store this in result and print out result. And see, the same exact list gets printed, but all on a single line. In fact, we can make this even shorter by just printing this list directly without saving it to a variable. So in one line, we can do everything that up here took 1, 2, 3, 4, 5 lines to do. So that's the power of list comprehensions. Let's take a look at some other examples. Going on here. So here's another example. Now I'm going to show an example of using the conditional part. So for our list comprehension inside of brackets, we have the expression for variable name in sequence. And now by adding a conditional line at the end, if I mod 2 is equal to 0, we're saying that we only want the powers of 2 that are in this list, where the number that we're raising to the power of 2 is even. So if I run this code, let's just take this and rewrite it in Replit. We'll do this all equals, so I to the power of 2 for I in range, whoops, for I, in fact, here, notice it can be any sequence, it doesn't have to be a range. Here we're just giving a list directly. If I mod 2 is equal to 0. Now if I print my result, this should give me I squared for i's that are even, so for 2 and 4. So 2 squared should give me 4, and 4 squared should give me 16. Let's see if that is the case. And indeed that's what we get, 4 and 16. If I got rid of this conditional, let's say I made this if I mod 2 is equal to 1. So for the odd numbers in this list, I want to do I to the power of 2. Okay, well, let's see what that gives us. That gives us 1 and 9, because 1 squared is 1, and 3 squared is 9. Or if I were to get rid of this altogether and have no conditional here, it would just do this for every item in our sequence. So we get 1, 4, 9, and 16. And I realize you can't see this, so I'm going to run it again here. There we go. 1, 4, 9, and 16. Yes, yeah, just kind of explaining what this does, though we just took a look together, but I'll point out here again, this is our expression, I to the power of 2. Then we do for I, which happens to be the variable name that we've chosen, in the sequence that we have, and then our conditional at the very end. And just read this out loud in English, in order. Do I squared for each I in the sequence if I mod 2 is equal to 0. And so notice if we didn't have these list comprehensions, we'd have to write code that looks like this. We'd have to write a for loop. Inside of the for loop, we'd have a conditional. Inside of the conditional, we'd have the thing that we're going to do. But our list comprehension lets us write this all in one line in a very pretty way. This is also very handy. That conditional part is very handy for writing functions that do filtering. And so, for example, if you want to write a function that, given a list, just filters that list down to only positive numbers, you can do the same construct. I'm just going to have my expression is just x itself for each x in nums if x is greater than 0. And so this creates a new list with just the positive numbers in our given list. And it's a one-line function. It's so simple and clean. Now, finally, I want to point out, I've been using examples with numbers. They don't have to be numbers in your sequence. It can be a sequence of any kind. And so here we have a string, Howard, which has 6 characters, H-O-W-A-R-D. We can do the exact same thing where for each character in Word, we're going to do the expression car.upper. And here, when we iterate over a string, we get back kind of one letter at a time. And then we're uppercasing each of those individual letters. So we get H-O-W-A-R-D. A list of the letters, all uppercase. Now I'll point out, a word of warning as you look at these. And you'll see this in class, in our classwork and in the lab work. List comprehensions are very powerful, but they're also very dangerous. They can get complicated very quickly, and so they're harder to read and debug, because whenever you go from having something written out in four or five lines and you try to cram it all into one line, which is effectively what a list comprehension does, it is hard to follow the logic sometimes. And so here is an example. Like, you can even nest these list comprehensions. And so this is saying y for x in text if the length of x is greater than 3 for y in x. So what does this even do? It's really very difficult to read and track down. And so you want to make sure that you use, first of all, good variable names that are kind of clear, hopefully, with what the item is that you're iterating over. And second, just because you can do something with a list comprehension doesn't mean that you should. So I encourage you to think about when you want to use them, especially like in interviews, it's good to show for very simple things that you can use them, but you don't want to risk making some logic mistake that you can't catch because it's difficult to tell what a list comprehension does.